if you indeed have such data, how do you figure out your velocity? You might object that that's not quite a well-defined question, isn't it? Because your velocity changes. You might start out conservative and run very slowly at first, and then as you warm up, you might run faster and faster. So you could object and say, when I ask for velocity, I should specify velocity over which time interval. Fair enough. So let's say that you run for 6 hours for some reason. Let us then divide your run into 3 2-hour intervals. Now, if you know exactly how far up north you are at every point during this run, then how would you figure out your average velocity on each of these time intervals? Well, this question is probably an insult to your intelligence because it's too simple, isn't it? Say you want to figure out your average velocity between 5 and 7 a.m. Then obviously what you want to do is at 5 a.m. you would check to see how far up north you are. Say for example, at 5 a.m. you are 100 north on state. Then at 7 you would want to check again. Let us say that at 7 you are at 104 north on state. Then what is your average velocity between 5 and 7? Well, let's see. During this 2-hour time window, you have traveled a total distance of 4 miles. Thus, your velocity would be the total distance traveled, or I like to call it total displacement, divided by the duration traveled, and that would be 2 miles per hour. I guess here saying that you were running was a bit of an exaggeration. Now, athletics aside, here when we calculate this velocity, what we did is we take this change in the y-coordinate and divided that by the change in the x-coordinate. This type of quantity has a name. Do you remember what that is? Maybe you remember it better if I call this rise over run. Now do you remember what this is? Yes, slope. That's the slope. Now, more specifically, that quantity is the slope of this line here. Thus, if you have a graph of your position with respect to time, then the slope of the line connecting any 2 points on the graph, that slope is going to be exactly equal to the average velocity over the corresponding time interval. Now, to check whether or not you understand, let me ask you this. Suppose you only have this graph and I don't give you any further information. Could you tell me, between 7 and 9 a.m., did you run faster or slower on average compared to between 5 and 7 a.m.? Let's only use a graph, not any information I put over there. What do you think? Well, whatever the average velocity is between 7 and 9 a.m., that must be equal to the slope of this line. Now, you see this line is steeper, it has bigger slope, so that means that between 7 and 9 a.m., you must definitely have run faster on average than between 5 and 7 a.m. Now, if the idea of slope still confuses you a bit, then let's just check that directly, and please excuse my bad drawing. Let's look here. Between 7 and 9 a.m., that's also 2 hours, but between that same time interval, you have traveled this much. Now, despite this graph being quite horrendous, you can still see clearly that this is much bigger than this. Thus, during the second interval, for the same amount of time, for the same duration, you have traveled a further distance, so you must have had a higher average speed. Graphically, this is captured by the fact that the line segment connecting these 2 points here is steeper than the line segment connecting these 2 points. Because on this line, when you move to the right by 2 units, you move up by 4 units. Whereas on this line, when you move to the right by 2 units, you move up way more. And that's what steepness means. It means how much the line rises on average when you move to the right a single unit. That's why steepness is captured by the slope, which is rise over run, which in turn in our context is just distance or displacement over time duration, which is another way of saying average velocity.